Well, we got 15 seconds, maybe, but I don't know.
So we'll start in 15 seconds. Welcome to the joint TEAS, MPLS, PCE, and CCAM session. The focus in this session is on young data models. The data models that we'll be covering in this session should be of overlapping interest to folks across these 4 working groups. We did have a joint MPLS TEAS session at the last IETF for young models. We found that very useful. The MPLS working group hosted it. We thought we would repeat it again here today along with the PCE working group. The TEAS working group volunteered to host it this time around. CCAM wasn't part of our initial plans, but there was this one individual draft from the CCAM working group, which we thought would be useful if it were presented here. So thanks to the CCAM chairs and the CCAM working group for being part of this on short notice. IETF note well, it's late Tuesday evening. You should be all well versed with this by now. There's a link at the bottom if you aren't well versed with it. That should give you more details. In terms of session logistics, recording is on. We are using Meet Echo. For folks who are presenting, there's a pink box next to me within which you need to stand while presenting. It would make for a better viewing experience for remote participants. For note takers, we would be using Etherpad. Please do add your notes on Etherpad. Your inputs there are always well appreciated. You can also follow us on Jabber. The agenda and slides for this session should be available online. These are the topics that we will be covering today. The TEAS topics are working group adopted work items, so we'll start with those and walk through the rest. Any questions, comments before we get started? I'm looking at my fellow co-chairs if they want to add anything.
You'll note there's more co-chairs in the room than participants.
No, it's both the same.
That's because some of the chairs are participating.
First up is the T topology model. Sure.
I'm Xifeng Liu from Exxon, reporting the progress of the TE topology data young model. So on behalf of the authors and the contributors, including Igor, Pavan, Tarek, Himanshu, Aska, Sergio, and the editors. Here's the summary of the changes we have done since the last IETF session. So I'll go over those items. We aligned with the new 8-wires network topology model. Previous version, we had a few issues with this generic topology network model. So they had a new version and fixed some of the issues we raised. So now we adjusted our model so that we can use their groupings, and also we adjusted the tree structure. So now they have top-level container networks. That's the difference we can see from this hierarchy. Others are in the YARN files. So also last IETF, we got feedback from the working group saying that we should separate out the scheduling part of the model to a separate document. So we did that, and we submitted to the netboard working group, and we presented yesterday. So we'll proceed in that working group for this piece of the model. And the previous version of the model, there are some pieces which is technology specific. In this case, will be packet switching attributes. So we separate them out, put them into a separate module. So, but now we still have the questions. This one should be remains in this draft, or we need to have a separate document for this. So that's one question we'd like to have answered.
This question was posed at the last IETF as well. The guidance given at that point was to publish that in TEAS as a working group document, separate out the packet contents, publish it as a TEAS document, TEAS working group document. And given that it does have some MPLS portions to it, the consensus, at least the informal discussion between the co-chairs, is to share those details on the MPLS mailing list as well.
Sure. And then we also did some fixes in the model. So we already presented, and we had the intention to include all the alternative information sources, but this piece was missing from the node, so we added that. We also added support for the when we do the request from client side to the server side asking for a topology, we have the capability to return multiple instances of the topologies. In that case, we added this attribute to indicate which one would be preferred. We also did alignment with the layer 3 network topology model. This is an ATORS document. We discussed how do we correlate this model with that layer 3 topology model. The decision is to have a separate model, but we will have reference from one to the other. In case of the congruent layer 3 network and the T network, then we'll have pretty much one-to-one mapping from one element in the T in the layer 3 topology model to another element in the T topology model. So this is what we ended up, and we submit this document separately. So this is the result. And so we have covered that document here in this presentation. We also worked with other EM design teams related for related work. In this case, we discussed how do we deal with the TE tunnels. So we worked together, and we got the alignment. So right now, both models can work together, and we share the same terminologies and types, and we can cross-reference each other. So that this is a termination point we added to the topology model, and which also will be used in the TEM model. So this is for the when we set up tunnel from one end to the other end, how do we specify the endpoint? We also discussed how do we do the modeling abstraction. This is an example. We have the example shows 2 layers. We have a node from 1 to 6 and some other node in between. And this picture shows all the modeling elements related to the topology model. So we have like tunnel termination point, node links, and everything in between. So if we map this into node in details, we'll see the picture like this. On the left side, that's the node structure. In that we have links connecting to this node. The orange box shows the line card where the links are plugged in, and the top blue boxes, that's terminating devices, can be the transponders and with some client-side multiplexing capabilities. So in the middle, we have some switching component. In general, the switching component can be blocking. So we won't have a full mesh. Then, so at the right side, we have an internal links. How do we connect to one link endpoint to the other? And so we also shows abstract the terminating device into this termination point. Put this abstraction into topology context, we'll see this kind of picture. We have the links connecting between the nodes, and we can set up tunnels from end to end. And there are some other discussions ongoing. So this is working in progress. We are trying to make the model to support multi-layer path computations, multi-layer topologies. So in this case, we have 2 layers, the orange layers and the blue layers. And so we're trying to make our models to cover both layers, and we can use the single controller to compute the path for that. This is still working in progress, and currently we have 2 ways to do this. We can either separate those hybrid nodes into 2 separate logical nodes and set up some links in between them, which is called Transitional Link. Or we can describe the relationship between the layers inside the node. Use that relationship matrix to describe the internal relationship, interlayer relationship. That's what they call interlayer lock approach. And the current plan is that we're gonna support both approaches, and because they are not mutually exclusive, and we can even model the network with one piece of network with one approach, another piece with another approach, and they can talk to each other, and we can still handle them. So we'll change the model to support both ways. That's pretty much what we have done and we are trying to do. We have a to-do list at GitHub, and we also welcome all the comments. Any question?
I guess not. Thank you.
Okay, thank you.
Thank you. Okay. Hello, everyone. My name is Tariq Saad, and I'm going to present today an update on the 2 working group documents that describe the Rsvp and TE-Yang models, the TE tunnels and interfaces Yang models. Oh, yeah. Okay. Thank you. I'm presenting this on the behalf of the listed co-authors. For reference, we are leaving the location of the repository where we keep the latest Yang models there. a high-level overview of what I'm going to go over today. I'll go over the updates from the previous revision for both documents, the open issues, and I'll describe the next steps. The first update that we made or introduced to this to the document describing TE generic model was to address the need to model TE data outside the device. The TE generic model contained data that is local, that has local scope, like interfaces and interface properties, device timers, and so on, and globally scoped, like tunnels and LSPs. So in order to model data outside of the device, we had to regroup the TE data and the TE generic model into generic and device specific. The device specific data went into a new module that we introduced, and I'm going to show an extract of it on the next slide. So this model here describes the device-specific properties. In there will be the interface list, interfaces list with their TE properties, and additional timers to manipulate LSP behavior specific to the device. The second update that we introduced, or basically it was to address the reusability of the TE generic model for different technologies. One of the basic or the initial design assumptions when we started working on this model is to make it technology agnostic, in the hope that we will reuse it for the different technologies, MPLS, OTN, and WDM. So the natural way to attach the generic model was we thought would be under a technology augmentation or technology route, basically, for each technologies, and then you would augment it with the additional properties for the technology. As is, Yang language is not allowed to attach the same module for under multiple places in the Yang tree. So there is some proposals being driven at NetMod working group, and I think they're converging on one solution. We're looking forward to this solution, and I think it's very useful for us to adopt the same approach to achieve reusing the same model for the different technologies. There are some limitations with that approach. We'll be following those limitations with the solution being proposed at NetMod, and we'll keep the working group updated on those. I'll actually go over the limitations that we're going to face in the next slide. Other updates we had to do with our generic comments and edits. Basically, there was ask that we reflect the actual path of the LSP. Regardless of the signaling protocol we're using, there is a record route that Rsvp would collect using signaling, but that assumes you're using Rsvp signaling protocol. For the use cases that Rsvp is not there, there was an ask that we would have a list of objects that describe the actual LSP path in the TE generic model. And for that, we've added that list in the TE generic model. The other update that we made was to address the tunnel termination point identification that Zhufeng had described earlier. Basically, we introduced a new ID to define or to describe the tunnel endpoint. Other small minor edits that we've done, we renamed the PSC acronym to MPLS. We thought this is less confusing, and we introduced a new model to hold the MPLS specific data. I know some people might not like it or might like it, but Okay, on this figure here, I'm describing the relationship of the modules that we've been that are described in the in the documents that I'm talking about. Basically, the TE generic model. Let me see if I can. Okay, so the TE generic model and the device-specific TE model, the Rsvp TE generic model, and the MPLS Rsvp model. And the arrow is actually pointing to describe the augmentation. If we had to mount or basically attach this to MPLS, the thinking is we would, using this mount capability, we will mount all of the TE properties or data to MPLS. And eventually, other technologies, I'm displaying here grayed out boxes that are not described in the documents, will have to be done. Other boxes that are grayed out in this figure are boxes that are future work that we're thinking to address in the subsequent updates. Basically, the PCC augmentation out to the tunnel model and the segment routing TE augmentation. Open issues, we want to close on the mechanism to attach our TE generic model to the specific technology or mount, whatever terminology we want to use. This we may or may not have to do any changes in our model, depending on adopted solution in NetMod. From our understanding of the solution presented earlier this week to mount, there might be a restriction not to reference any leaf outside the mount sandbox. So as is currently, our model is referencing the interface list. So we will have to address this somehow. Okay, I think that's about it on this. If there are any questions, I'll be happy to answer them.
Throw from Huawei. Is it working? Yeah. Can you go to the slide where you had the PCC, IETF95-TEAS-20160405-1740? Doesn't matter. So you were thinking, but we in PCEP working group, our aim was to have IETF PCEP YAG, which is kind of generic, whether it is any PCEP speaker, a PCC or PCE. What is this IETF TE-PCC.YAG?
Yeah, so the thinking is any specific additional data that the PCE server would give to the PCC client, you would have to store it on the PCC, and you would have to model it as well. So this is why we're introducing this additional augmentation of PCC properties, whatever you want to store on the device.
I think we can discuss this offline.
Okay.
We have the same idea, but our thinking was, shouldn't it belong in IETF PCEP.YAG? What is the demarcation of what is IETF PCEP.YAG and what is IETF TE-PCC.YAG?
Yeah, so it's grayed out still. We haven't closed on how we're going to address it, but we are thinking.
My suggestion would be, let's keep it in IETF PCEP.YAG. There is something that we do need to add in IETF TE, which is things like when you configure a tunnel, whether this tunnel needs to be delegated to PCE, which is definitely belongs in IETF TE.
Right.
But what is, as you said, state coming from PCEP?
Right.
I believe it should be in the PCEP YAG.
Okay, so let's talk about that. Sure.
Hi, Cyril Margaria. At last IETF, you mentioned that the model will cover the device and more the controller, so the aggregated view.
Yes.
And so I had a look to the model, and it's not clear. It's clear to do how to do that on the LSPs,
right?
But not on the tunnels because you are missing the source. So where can I find that?
Yeah. So to be able to model the network, you want the data to be globally scoped, right? And we did have a discussion within the authors on this topic specifically. And because the tunnel is keyed by name, we could have introduced the source as an additional key so that it becomes uniquely global. But we thought because it's a name, you can prepend it with the router name at the beginning, and the name becomes globally unique for the tunnel. Now this is what, and in addition, basically all the implementations out there, we did a poll and all implementations support this name-based tunnels. So we thought it will be something that
This sounds
suitable.
implementation specific, and is it described in the draft currently?
The key for the tunnel list is a string-based name.
Yeah, but how to do it for control networks? Is it
How to make a globally unique name? It's pretty straightforward.
Oh yeah, I can think already about two different.
But
formats.
we can make it. We can definitely make it clear if it is not.
Yes, that would be appreciated.
Sure.
From Huawei, just also wanted to thank the authors on taking the comments from the PSEP and preparing a generic IETF. Thank you for that.
Sure. Thanks.
Pavel from ADVA. So actually, people from ADVA had the same question about the source IP. And did they understand you correctly that you want to embed the source IP address in the name and require everybody to do that?
That's how we thought of
That's
it.
your way of putting the source IP address in the model?
It's the source name. We didn't. Yeah, I mean, you could put IP address, but we thought about embedding a distinguisher within the tunnel name. And if that, that is not suitable, let's discuss that, maybe on the list. I mean, embedding a source by itself, it's not a big problem in the model, but we thought all of the vendor representative thought it's possible to do a name-based, globally unique.
No, I understand
Identifying.
that the name can be globally unique, but that's without that.
Okay.
So like source IP is not valuable information like in a tunnel?
Sorry,
Having a source IP.
the source IP itself is valuable, but we're saying is the key has to be global. That's.
Yeah, the question is whether you want a multi-part key or a single key. And seems like what Tarek is trying to say is almost all vendors have just a tunnel name as a key.
So then you don't have to make the source IP the part of the key, right? But you can still have it. You can keep having the name as the key, but you can have
If the name is enough to make the key globally unique, then it's enough. If you need the source to make it unique, then you need the source.
What if I want to have the source for display? What if I want to have the source IP just to have it in some field?
You can have it as an attribute. The question is, do you want it to be a key?
No, I just want to have it.
Attribute, yeah, that's fine. It's there, actually. We have it in the model. We have the source address in the model.
Okay, I have to look again. Thank you.
Blueberger. Even though I'm not sitting there, I am a co-chair here. A few things. Naming.
Naming.
So you didn't want to use PSC, so you used MPLS. To me, that is going to lead to confusion down the road. And because we have some base models which are MPLS, which we are going to use for things that aren't packet, but we're going to talk about MPLS as packet. And I respect that PSC is a GMPLS-centric term, so avoiding it is just fine. Maybe just use packet.
That's another option. The reason we were, swayed towards MPLS is there will be other protocols augmenting the MPLS base, MPLS LDP, MPLS static LSP.
Then call it MPLS packet.
I guess it's possible we
Just
can.
saying MPLS, I think, is going to lead to get lots of confusion, and I don't think it's a good idea.
MPLS is only packet.
What's that?
MPLS is only packet. I don't know if there's other MPLS.
I think it's going to lead to confusion. I'm interested in what the other chairs have to say also.
Yeah.
Certainly the working group also.
Sure.
I think having MPLS implicitly always be PSC is going to cause confusion when we look at building blocks. I had a couple of two other points, but maybe we can get some responses, discussion around that. And I'll be sensitive to time, so I'll look to the guys in the front to actually do the timekeeping here.
Adrian Farrell. So suppose there was another grey box that we wanted to show on here for IETF Rsvp GMPLS YAG. Would you then have the conversation that said GMPLS cannot be used to control packet?
Well, GMP, okay, that's a good question, actually. The way we're describing Rsvp MPLS is for packet. I think it's more or less close to what Lou is hinting to, but we have augmentations of the Rsvpt generic model. So if you want WDM augmentation, we expect Rsvp model to show up here, augmenting the generic one.
Okay, I read your IETF Rsvp MPLS. No, I guess I misread that. So we had previously talked that the core TE, Rsvp TE, should be agnostic
Correct.
to protocols.
That's correct.
To data plane.
And this is the generic or core, yeah.
So that's generic. So
Yeah.
where's Rsvp TE? Yeah, so that's that one. So I think you just said the different answer to Adrian.
I did, well, he was asking about GMPLS packet.
Right. So
And
GMPLS packet would be an augmentation hanging down, you think, below there?
Probably, yeah. For bidirectional, for example, yeah.
Well, I would hope bidirectional is part of the core, because bidirectional applies to all different technologies except for classic Rsvp-TE. So I would hope you would sort of reconcile that some other way. So, or are you saying that GMPLS is a peer to Rsvp MPLS, and then all the GMPLS technologies augment underneath that?
Yeah, so that.
Okay, actually, I'm going to back up. Until there's a GMPLS in this picture, I don't understand it.
Sorry, can you repeat again?
Until you have GMPLS.
Right, I don't have it at the moment.
Understand it.
Correct.
At least at this level.
Right.
I do think you should consider using some other term for packet than MPLS. I think it is confusing. Look at the discussion already we're having. I would like to talk a moment about how you are going to, what you're thinking of the document split and what's going to go where. But do you want to say something before that?
I just want to ask you something. Lou Anderson, question to Lou. What is the cause of the confusion using MPLS, and what is better using packet?
So I think we're going to end up with a bunch of technology-specific models. Those technology-specific models are going to hang probably underneath something that looks like GMPLS, probably, but maybe. And until we see how everything's going to fit together, as I said, I'm going to take a step back. Remember, I said I'm going to take a step back that I don't understand how this is going to work without the GMPLS in the picture. So when we add GMPLS and GMPLS packet, and we have MPLS and MPLS packet, until the authors have a proposal on how to reconcile all that, I'm not sure how it's going to hang together. So I'd like to see their proposal before drilling down more.
I just trying to figure out what you're really asking. So
I'm asking for them to add GMPLS and GMPLS.
I think in the interest of timekeeping, we should probably take this discussion offline. But
right. So as chair of TEAS, I am asking them to add that to the picture so that we can have a full discussion.
Okay, Lou, I understand what your ask is. Basically, we don't have a GMPLS module at the moment.
That's fine. You can add
we
this
will,
picture of how it's going to fit in,
right.
just like you have the great pictures.
Sure.
Also, I'll make it quick, being sensitive of time. You have an addition of a use case for schema mount that we have previously talked about as likely to happen, and I say we as the routing design team.
I see.
The fact that you're actually using it is really good. Please bring it to NetMod. In particular, highlight your specific use case of mount one model, and that you think that the restriction for what they're already looking at is too extreme for your use case.
Right.
That's very useful information.
Sure. Thank you, Lou.
So, Lou, are you really saying that we have a need for both packet and MPLS, where MPLS describes a specific technology and the words are not synonyms?
I'm saying I don't understand how the picture fits together.
Okay.
Igor Bruskin. I think I agree with Lou. It actually brings a bit of confusion. If we are talking about technology-specific models, it should be basically technology-specific. I like to call PCS. PSC, sorry, PSC or Ethernet or Lambdas or TN. MPLS, it's confusing because MPLS could be for different reasons. And as Adrian said, MPLS could be a JPLS, could be still talking about packet switching, right? And MPLS could deal with different things as well, right? So yeah, I would suggest to go back to PSC.
Actually, we went away from PSC because it was a bit confusing. I mean, the question now is between packet and MPLS, but PSC, you know, you could use the term for different things in GMPLS, or, you know, like I'm sure.
Let's see your proposal.
All right, thanks.
Okay, so shall we move to the next presentation,
Yeah.
Tarek? So anyone who's looking at the agenda online may be under the impression we're running 10 minutes behind, but actually the agenda has the wrong timing written down on it. We're actually bang on schedule. The session today finishes at 7:10, not 7 p.m.
But we were 5 minutes ahead, and now we're on schedule.
Yeah.
I've tried to make it fast as well. The next one.
It's the same slide.
No. Okay, the next presentation I have, I'm going to give an update again on two Yang models that are driven in the same draft, the MPLS base, and the second one talks about data for static LSPs. So I'm presenting this on the behalf of the listed co-authors again. Next, please. Oh, sorry about that. Bit of background. So we have two Yang models here, MPLS base, and which basically serves as a basis for configuring and managing the MPLS subsystem. As is now, it augments the core routing data model defined in netmod routing config draft or working group document, and we're adding specific MPLS switching data or data. It defines the MPLS list of MPLS enabled interfaces and properties, and it's expected to be augmented by other protocols like TE, LDP, and LSP static. For example, TE I showed you on the figure from the previous presentation. And we will talk about the LSP static model, which will be augmenting the base MPLS as expected. In terms of updates, so the draft was initially introduced in Yokohama on IETF 94. We had to make a change to the augmentation path because the dependency module that we're augmenting changed their path. So the draft as well has gone through a MPLS RT review, and we've received comments from two reviewers, and we would like to thank them, Hoop and Carlos. There is interest that we received interest from multiple parties, basically to generalize the static LSP model. The way it is defined is MPLS specific, and the ask is to generalize it to multiple technologies, just like the approach we took with the TE tunnels model. So the first open issue at the moment is what I just spoke about. Our objective is to make the MPLS static LSP model more generic and applicable to multiple technologies. For this, we are proposing to decouple the MPLS specific properties from the generic properties and have them in separate modules. And then utilize the mount capability just like we are planning to do with TE tunnels model. We expect more augmentations for the technology-specific data to this generic LSP static model. I put them as open issue, but they're reviewer comments that we received just recently and we haven't addressed yet. So we have received a comment saying that the draft has two modules, and the suggestion is to split them into two drafts. There are other comments and nits coming from Hoop, and we will address those. And we agree that splitting might be a better approach, specifically because we want to generalize the static LSP model from to become non-MPLS. Again, the second set of review comments we got from Carlos, again suggesting that we split into two separate documents. There's a term, load share, that is applicable to multiple paths, basically weighted load balancing or weighted load share on different paths. So we can clarify that on the list. Other nits that we will address. There is a question about the index of the label. The way we define the index is just a key, basically defining this specific label. It's not an offset in the label stack. So a huge number does not mean that we have a huge label stack at all. It's just a unique number. Next steps, we will address outstanding comments. We are soliciting more feedback from the working group. And we would like to close on the approach to generalize the static LSP model. And we would like to continue with the working group adoption, at least for the base MPLS model. That's it. Any questions?
Adrian Farrell, traditional apology. I've just been reading your Yang model while you were talking and for the first time, so sorry. Static LSP, well, I'm trying to work out whether what you're describing in that model is an end-to-end static LSP, or whether it is a static LSP as seen at one network node.
Yeah, so it's actually end-to-end, and for this I will utilize the backup slides. So we have the notion of in and out segment and multiple operations that the LSR or whatever technology. So we are defining here impose, swap, and pop. Obviously, some of them will apply to certain technologies and not to others. But the LSP, we have a list. I hope we have it here, but we have an operation that apply on the head, on the transit, and on the egress.
Right, so it's a bit like an explicit route with all the labels mentioned.
That's correct.
So when I use the static LSP model as an application using it, do I see anything different apart from one bit that distinguishes between a static LSP and one that is going to be signaled using Rsvp TE?
So most of the operations will be configuration driven in the static LSP model, as you expect, because it's statically configured.
That's down there. I'm a user, so I don't understand that stuff in the network. When I ask for an LSP as an application,
right,
and that LSP is going to be provisioned by signaling,
right,
do I need to do different things from when that LSP is going to be provisioned by whatever your favorite configuration protocol is?
Exactly, and I'm trying to answer that. So Rsvp will create state and then provision the rewrites and whatever goes with it. It's a state-driven LSP creation. And in this case, we have configuration data that persistent. Basically, your cross connects and everything is configuration driven. And what we're trying to model is what configuration and what operation that I need to be invoked on a specific label incoming, and maybe you want to impose multiple labels on the outgoing. And we have all the examples listed. Now, Rsvp, it has all bunch of state and timers and all that needs to be modeled on its own. There are some configuration items in our model, but there is also state used by the protocol, right? Created by the protocol. So at the end of the day, I think in the data plane, they will look alike. The LSP created by Rsvp and the LSP created using static, they should look alike in the data plane. but we're not modeling the data plane yet.
Right. And so I suspect the chair's going to tell me to go away and write an email in a minute. I understand the data plane side of it, and I understand the group in the middle, which is actually, what the coders have to do. And I'm trying to ask the question, when you're up there above it all and you're requesting, you're either reading or writing an LSP, isn't actually all the information exactly the same? Just like it's exactly the same in the data plane, isn't it exactly the same up there?
So the interface we're exposing is basically a net. I mean, what we're trying to model is a data model here, and you could use for netconf or whatever interface. And how does it translate down to the data plane? That will be similar to what comes from Rsvp. But this is mostly configuration, driven, just like a static route that you have to configure.
Please, can we put this one into an email now? Because we ran out of time, sorry.
Let's rephrase, you have IETF which works at the controller and which works at the IETF device, which will work at the device. Is MPLS static LSP only for the device, or is MPLS static LSP can be used at the controller as well?
So the controller can provision a static LSP using this model, but it will be configuration driven, items that will come from the controller.
So there is a way to configure the whole explicit part using your model at the controller.
Right.
George, be quick.
So you mentioned you can maybe push on multiple labels.
Yeah.
Are you considering how a static segment rounded LSP would look? Is there any engagement with the Spring at all?
For MPLS Spring, static LSP for us looked like as if it's a static LSP. So you would need to define an incoming label and outgoing label, which probably would resemble a nodal segment or adjacency segment.
Or it could just be a stack of labels.
Or a setup.
Posed and then acted on each hop, but the action is always pop.
Right. Yeah.
Just want to make sure that all fits and they ought to be informed of that.
Yeah, we think that the operations are the ones that we define cover, even segment routing operations, which is impose, swap, and pop.
Really sorry to cut across this conversation, guys, but we ran out of time for this slot. So can we please continue this on the list?
Yeah, just again, from the chair's perspective, it's Lou. I think you have at least a couple of models here, and that you should think about separating them. And the provisioning of what happens at a single node is quite different than provisioning a whole LSP, and you might look at separating those two things.
Okay, thank you.
So could we have the next presenter, please? Rajiv.
So when you say list, which mailing list? I'm spamming all three.
I think when I say continue on the list, I think probably the right list is the MPLS list. Would that sound right, Laura?
I think the list is the list of the draft. So if the draft has,
the draft is a draft.
No, but I think it's a generic comment. Even though we're a joint session, the process is being run for each draft in a specific spot. So it should be the draft in the name. And one other thing on that previous one, the intent is that it would cover both TE and non-TE, which is why we said MPLS.
So is Rajiv Asati in the room? Okay, well, we'll try to come back. So let's go to the next one. This is Guangying Zheng.
Okay, this about the MPLS SPPing YAM model. Hmm?
No, it's updated. It's updated. All the MPLS.
Okay. This is about the MPLS pin young model definition, mainly for the configuration and for schedule. What is addressed in the revision 3? We define the young data model which based on RFC 4379. And we define 3 containers for the control information, schedule parameters, and the result information. And the comments from Meredith and the chair's review are addressed. What's updated since the IETF 93? Firstly, we keep in line with the IETF MPLS RFC 4379 bits, which work ongoing in MPLS work group now, and this 3 RFC are incorporated. And the leaf node for traffic class is added in the control info, which references the RFC 5462. And update the definition of target effect types to make it comply with the RFC 4379 definitions, and clear some description which previously we defined not clearly, and some editorial changes. For control information, first we define the configure true parameters which control Rsvp test keys, and support most of the target address types defined in the RFC 4379, and support reply mode defined in this RFC. And parameters like the timeout, frequency, and probe count, and date size, and date field, which we defined to control the test keys. And the schedule parameters define the test keys, the schedule parameters of Rsvp test keys, like when start, when stop, and for the start mode we have 4 start mode, like the start run now, start at a certain time, and delay start at several seconds, and start at a certain time daily. And 3 stop modes, like stop run now and at a certain time, and delay stop of several seconds. And the result information mainly show the result of the current Rsvp test case. The PIN-MIB RFC 4560 is referenced for the parameter definitions and the RTT. And probable response is the number of responses received for the corresponding Rsvp test case. And next steps, we will get comments on revision 3 and seek contributions and collaborations, and seek the MPLS workgroups adoption. Now the authors think it is ready for putting the workgroup adoption, and now we seek the workgroups opinion now, and continue discussion on the mail list. Yeah, and that's all. Okay. Any question? Okay.
Okay, next up it's Dhruv.
Thank you. So here we have the PSEP YANG. So the aim with this YANG model is to have the management of the config and the operational state of a PSEP speaker. A PSEP speaker being both a PCC as well as a PCE. We started off with our base RFC 5440, making sure that all the elements of a PSEP session and all session management related things are handled. We later on moved to the stateful PCE part. So that's where we are with our model. The recent change that we did since the last time we presented, which was in Prague, we got some comments from Oscar, so we handled that. We added a little bit more description on how the model would be used, especially around the LSPDB part. Some other comments were related to adding timestamp, putting all the statistics together and putting it in a container called PSEP stats. Some of the old model information like entity address was still pending in the notification, so those things were cleared. Another thing that we had in our current draft, which if you open, which is before the IETF was published, was we had captured all the PSEP specific parameters for an LSP that we were maintaining in the LSPDB inside the PSEP state, but we were not carrying any other parameters. So now, since the IETF has gone ahead and written a generic model which has the LSP state, our aim is to refer the information to the LSP state from the PSEP model, which is what you guys will see in this proposal. So this is what's there in the Git, and we are going to continue to update it. What we have done is have a container for LSP ref and put the reference for leaf ref for all the keys inside the T model. And this is what you see here. So this is where we are right now. Now we still have some open questions that we are discussing during the IETF week and trying to move the model along. The one point which I also already pointed out when Tariq was discussing was, where do we put the, for a particular tunnel, I would like to delegate this tunnel to the PCE, or for this local tunnel, I want local compute, or I want PC to compute, whether in passive or active mode. So where is the right place to put that information? And when we do IETF at a controller, when we want to set up a PC initiated tunnel, which is the right place to mark that? So our gut feeling from the PSEP authors is, we feel maybe the IETF Yang may be the right place. We'll continue to discuss and get, okay, if Tariq wants to add something, maybe.
I do. Tariq from Cisco. So I see that the IETF device model that we've just introduced is a fit to be augmented with these properties. It's device-specific properties. It's not going to be on the controller or the PCE.
Yeah. So I think the first part, yes, what you just pointed out, which may go into the device, but when it comes to the PCE-initiated tunnels, that we want to put it to the controller. So now it's like, it's a modeling question, whether we kind of merge it together and keep it generic, or whether we put IETF PC initiated there, but only the PCC delegated at the PCC model. So this is something that we can figure it out, but the gut feeling is that this belongs in IETF rather than in the config model of PSEP itself. The second thing that which is a common question, I think, across people who are working on Yang, we look at TE Yang, which is trying to maintain state with the config, especially the intended config state. But what we had done initially was followed the generic Yang, like looking at IETF interface, etc., and keep config separate and all the state together. So the one question that we have is that, is it up to the module authors, or does the working group within the MPLS has some guidance to us to pick, or is it just up to what the author wants to do? Do you want to have a comment?
Yeah, so I'm wearing too many hats nowadays. It's Lou. So as NetMod co-chair, I'll say that this whole topic is an open topic.
Okay.
And that the working group is trying to come up with a solution in short order. Will we be successful? I have no idea. I think you'll know more by Berlin.
Okay.
The objective right now of those people working on it is that there's nothing that each model writer will have to do in order to support OpState, and that there'll be some tooling that will provide the additional elements that we need. That's the hope. Whether or not that working group is successful, I don't know. I think we'll have a good idea by the next IETF.
Okay. So right now the suggestion would be to keep the drafts as it is. Wait for next IETF to have some.
I would say don't go decorate your MIBs with intended and implied, your MIBs, sorry, models. Yeah, whatever. It's been a long week already. Don't go decorate your models with intended and applied if you haven't already done so. If you've done so, don't go change it back.
Okay, thank you. What's our next step? So we are adding, this is the order that we are gonna add more details in our PSEP YANG. We are starting with some security, which will include the old ones like MD5, as well as the new PSEP-S and the TLS feature. Further segment routing, adding association so that our primary and backup paths and those things can also be handled well. So this is where we are right now. We would request other working group authors who have documents in PSEP to start helping us out in making sure that we are modeling the YANG correctly. Also, I think from now, we would request if the manageability consideration can have a little bit more details on the YANG model, so that as a YANG model editor, we get a little bit more guidance from our PSEP documents. So the YANG right now, we have it in the Git, which is the working. So we'll request other people to help us out in making this PSEP YANG with more features that we are currently working on. And then I'm not sure in the joint working group session, how does this work? PC working group adoption call. That's, I think, for the management to figure out.
I think we should probably ask a question again in PCE.
Okay, that's a good idea.
I'll have to make some time to do that tomorrow.
Okay, thank you. Any questions? I think we covered. Thank you.
Hi everyone, my name is Xian from Huawei. I'm presenting a CCAP draft actually with a very long name. It's YANG models for the northbound interface of a transport network controller, requirements, functions, and list of YANG models. So I'm presenting on behalf of a list of authors as well as contributors. As you see, there are already many YANG models in IETF, and when you approach a YANG model authors, you're asking which interface you can use this YANG model. They will say whatever you want to use. Here, we want to be clear about the interface we are actually looking at to use YANG models. So you can see from these two use cases. The first one is the data center interconnection. The other one is the control of multi-domain networks. I want to emphasize that we are really looking at the optical transport network, so it's more focused, but it might be applied to other technology as well. So if you see from the two use case that we actually focusing on the interface, which is not to the transport network controller. It can be between a data center controller and the transport controller, or between an orchestrator or coordinator, whatever you call it, and the domain controllers, as you see from the right side of the graph. And we actually first list the functions we want to see between these interfaces, and then we check existing draft to see where the existing work fits into the requirement we have. So you can see the table here. We have a list of function on the first column, and in the last column we show the models which can be used to fulfill that function. So the models here, you can see that in the T topology, also we have the technology specific ones, the WDM topology, and also ODU topology. And for the tunnels, we have the T tunnel, and we are also looking at whether we need extensions to extend from the T tunnel to cater for the ODU tunnel and OCH tunnel. And the other one is the service request. Here, actually, I will show in the next slides that we think there's a need to have a service model which is not tied up with the details of the technology for the client usage. And the other one, the final function, which is the virtual network operations, it's actually an advanced feature, but we see that maybe the topology draft I mentioned before can still apply to this function. So here it's just showing the YANG model tree of the service, the transport service, but here it's only focusing on connectivity. We're also thinking about other services as well. So here is just our first our first try of the capturing the service connectivity service model. As you can see from the model, maybe it's not really nothing particular focus on the optical transport. It may be applicable to other technology as well. So I think that's why the draft is presented here. So I'm not actually presenting any details. If you're interested in the work, please read the draft I posted in CCAMP working group. Any comments? Oh, by the way, we're actually working closely with the TE topology and also the TE tunnel authors, trying to see, any changes needed to the model itself.
Sir Magalia, a question regarding the service model. This looks like a lot like a tunnel information, and why not augmenting the tunnel information?
We can do that. Yeah, that's a good feedback. But at the moment, the reason why we do it separately is because for the existing tunnel model, you can see a lot of details like name the administrative group as well as the name the SRG. I don't think the client wants to touch, to that details. That's the reason we motivate us to make it separate for now. Yeah.
Yes, but I don't recall those to be mandatory.
Okay, Tarek, again, I think it's very close to what my colleague here was asking is, I was expecting that some of these are augmentations to the TE tunnel, but I think we can talk about it because some of them are familiar. We did introduce in the generic model and they are there, so.
Okay, let me ask you a question. You see here at the bottom, we have the schedule. How to say, I think it's actually generic. Do you think it's possible to put in the TE tunnel, or you was just to do augmentation from there for?
Yeah, I think if it is not generic, it should be augmentation. That's my point.
Okay.
We can classify generic and not generic, but maybe you meant to say this is an augmentation. I wasn't sure.
I'm not sure yet.
Okay.
Yeah.
All right.
It's Lou. What about what we're seeing here is specific to a specific technology?
You mean this model itself, or?
Yeah. Because you're aiming CCAMP. So CCAMP is for technology-specific definitions. So what here is a technology-specific definition?
This model itself is not really technology-specific. I will take out from the draft, but from you see the use case we focus on is really technology-specific. That's the reason why we put the draft there.
Okay.
Yeah.
We tend to have use cases that are technology specific, makes perfect sense. I think that the details then belong in TEAS. Okay. And you still have to address the other issues, but we'll address that within the TEAS working group. And clearly we should give the opportunity to the CCAMP chairs, who I think are in the room, if they want to say anything. Well, the CCAMP chair in the room, or at least one of them, is nodding their head no. So I'll take that as agreement. Now he's nodding his head yes. So that's great. Thank you.
Adrian Farrell. I'm really interested by the piece of this that is the scheduling piece. We've got some work going on in TEAS around scheduling LSPs and things from a control plane architecture point of view. What I see in this Yang model is a very generic scheduling policy, right? You could schedule anything in the IETF with this set of objects. And I don't know what the answer to this is, but somebody probably needs to talk to the various Yang model people about, do we need to pull this out as a separate model? Do we need to go to super and put it in a separate model? I don't know.
Actually, I can answer that question. And so, as Xufeng already said, I'm not writing my own schedule part. I'm actually using their grouping. So it's already in a different draft in that mode. I'm actually reusing that part. I'm not reinventing the wheel.
Rajiv Asari, Cisco. And because if it's related to the northbound system, specifically around the orchestration system and not really relating to the devices themselves, yeah, thank you. Following this picture, the red bidirectional arrows, then do we really need to have the specifics in the model that defines, describes each and every node where the service needs to be instantiated? Wouldn't we want to have a lot more abstracted actual model where the controllers or the intermediary would actually know all the specifics, and the orchestration system would only convey in the model, using the model, really abstracted information. I need a tunnel. Yeah, needs to have protection. Without specifying all the specifics around it. So just curious if you have given any consideration for abstracting this out for making it suitable for the northbound communication.
I think you are right to some extent. I mean, for service model, it's really generic. It's not really, doesn't care about technology specifics, but there are some use cases, for example, for use case 2. For a multi-domain optical network, they still need to expose some detail, which is probably technology specific. So we really need to have a use case where you see whether it's more technology agnostic, they don't care about the details, or they do care about, yeah.
Thank you.
Rajiv. Thanks. So while Rajiv is making his way up, who has some blue sheets? Did someone eat the blue sheets? Where are the blue sheets? Yeah, is anyone not signed them? Hands up if you're not signed the blue sheet. Excellent, thanks.
Good job.
Okay.
Thank you. Whoa.
I hope you weren't wanting to look at those slides. Someone just killed your monitor.
Thanks a lot. So this shouldn't take long. So you got the third revision of the LDP MLDP Yang draft. Lots of good changes in this revision. Here's a summary of the changes that we have made, and I'm gonna go through some of them and jump into some of the specifics on the subsequent slides. So first, we certainly had the privilege of having our chairs actually read and provide us the comment, and we went into the length to actually address all of those comments that we received. We actually made some of the specifics around how the tree is organized very clear in the draft. So there's a lot of good illustration and figures you find right from the high level to the actually low level. So that's some, and you're going to see a snippet on the next slide. The third, within the design team, we had quite an extensive discussion to clarify the usage of these terms: neighbor, session, peers. Many times we found during our conversation that we got a little bit loose in using these terms, and when we got to actually putting them in the Yang model, it became slightly difficult for us to all stay on the same page. And part of that had to do with how these terms were used in 5036, and part of them really had to do with how we started to have our own interpretation around them. So we went really strict with these definitions. So if you get a chance to read the drafts, certainly look at these definitions and the way we use them. So in this version 3, we have really fine-tuned the usage of these terms and rest of the Yang model around them. In the revision 2, we didn't really have any representation for the state, so the operational state, which is the derived state. And now in version 3, we got that well covered now. Of course, there's still some more modification that might come along once we go through the time cycle, and once the NetMod group working group decides what direction they want to take in terms of how the tree needs to be organized for a state, we're going to align that. And because of some of these changes, we went through and really cleaned up the entire document. So hopefully now, if you get to read, you should not get sleepy within 5 minutes. You should at least stay awake for 15 minutes. We limited the number of authors in the main section. So here are the specifics of Ross's comments. All of them got addressed. One thing that's missing in this slide is the LSR ID that Ross had pointed out, and we had quite an extensive discussion, and thanks to the chairs who actually took a request and socialized with all of the ADs to get some consensus on the router ID usage across the working groups. And I think that was absolute kudos to all the chairs for helping us get through that. So here's the high-level Yank tree looks like. Okay, and here's a picture. Of course, there's a better one in the draft. Basically, you have the config with the state in this container, and then you got RPCs, this container, and then the notification. Of course, then all the relevant details go in this tree. So if you nothing else, if you were to picture like how does LVP, MLVP tree look like, this is what you need to walk away with. That's really the high-level organization. Everything else is all inside these large containers. So I mentioned this fine-tuning of these three terms, right? Neighbors, session, and peers. And I'm one of those who have been using these terms very loosely for many, many years. And with this, and I'm going to take a pause for 10 seconds and let you glance through it. With this, we actually fix it. And I hope this also goes into other working groups, because this doesn't just apply to LVP. It applies to BGP at minimum. Okay, my pause just ended. Neighbor has nothing to do with exchanging information such as binding label information. Neighbor has nothing to do with TCP constructs. The definition of neighbor in this case is all around, hey, I know about an entity connected to the other side of the link or somewhere in the network, whether it's basic discovery or targeted discovery. Session is a TCP session with the neighbor. And then peer, that we got past having a session, we're now exchanging bindings, whether it's address bindings, label bindings, or both. So that's really the definition that we sort of fine-tune. And thanks to Loa for pushing us to actually get really crisp with this. So now when we go into the model, if you think about config less but more about the states, you're going to have to, you may have an entity, a remote entity that may be in one of these three buckets. So now we can have a much more strict way of tracking where that remote LSR, in what state the remote LSR really is in. Loa?
So, Loa Anderson, I'm a bit split here because I'm an author of the LDP specification and I'm also a member of the design team. And I actually have, when I see the slides on the screen here, I don't think we're doing anything more strict when we're doing in Rsvp5036. We're doing exactly the same thing. These are the definitions that we have in 5036. So there is no, we are actually doing the same thing as we did in 5036. That's what I want to say. We're not doing anything stricter.
Okay. Oh, I think, yeah. So, I can add some more points into the list on that.
What we're doing stricter is we are going back to what we did in 5036 like 12 years ago, and we are getting away from the rather loose use of the concept that we had in 12 years in between, and now we are back again to the same point where we started.
Thank you, Loa. Derived state, right, or the operational state, as many of you would refer to. So we added that in the version 3. So there are really 4 areas in which we are tracking all the state information. So the first one is neighbor adjacency, the second one is peer, third one is bindings, and fourth one is capabilities. Here's the snippet of how that looks like. again, from the high level standpoint, the applied state is not in the derived state yet. And this is one of the conversation we have been having. In fact, I have another, we have another email thread going on the NetMod working group mailer list. The three school of thoughts. Either you could have your config, which is your intended state, along with your applied state in one bucket and derived state in another. Or you could have intended config and in one and applied and derived in another. Or third scenario, third variation, you could have all those three things in one bucket, one container for each and every field, right? And the pros and cons of how you want to go about it. And right now, the Yang guideline out of the NetMod working group has no recommendation. And I personally have a problem with that. I think there should be a guideline so that LDP doesn't end up doing things the way A versus Rsvp comes along, and I'm making this up, nothing specific, does it B, BGP comes along and does C, and then me being a naive reader, I'll scratch my head and struggle to make sense of it from basic parsing point of view. So I wish there was a guideline. There's none. Right now, the way LDP is written is just one of those ways. And if there's any comment or any feedback on that, any preference, would love to hear that. The next item, and this is the second last slide.
We should pause and take a comment from Luke.
Yes.
Hi, Lou Berger. Were you in NetMod? Yes. Were you in NetMod?
In that meeting yesterday? Yes.
Did you hear Andy's talk at the end?
Yes, he had it slightly.
Andy, there's a update going on guidelines to model authors, and Andy said, well, we'd like to look at other things we should add into the guidelines. So it'd be really good to make that your comment that you just made, that you'd like to see some guideline on that, specifically to Andy and to the working group. Thanks.
I sent an email this morning already on that. Yeah.
I'm not caught up on email, sorry.
Okay, that's fine. Thanks for pointing it out.
Justin, could we have a goal for young design team to come up with considerations in Berlin? Would be great if we could kind of finish up by Berlin what we are doing, because this question comes up every time. We know OpenConfig wants to do one way.
Yeah, so it's an action item for the NetMod working group at this point. So what's that? Right. So one of the changes from before this meeting to this meeting is now that's a specific deliverable inside a document that's being worked on. So there's been movement.
Yeah, I mean, at minimum, if even if there was not a recommendation in the document, Louis, what would be really nice? Pros and cons. At minimum, there's nothing. It leaves it open, and it's an interpretation thing at that point.
I think it would be great to have specific guidelines from those folks who've been working on this thing for a while, and
I agree.
Think that there's a good way to do it. NetMod's the right place to add that conversation.
I appreciate your support. Thank you. The next item, so I briefly mentioned LSR ID. So LSR ID, router ID, all of us tend to think of as configures IP addresses, and big change that we made is across a document. We've decided to use dotted quad. We moved on from using UN32 and no more IP addresses for sure. So the LSR ID is all limited to just the Yang type of dotted quad, and we really hope all of the protocols outside the MPLS working group, of course, and also adhere to it. So there's one way to define router ID, whether that is being used by LDP as a protocol, BGP, OSPF, or pick your next favorite protocol to begin with. So that way, there are no two different ways for us to configure the router ID on the box. So, and I hope that that goes along and gets embraced by everybody else. So we still got some of the things that on our list, on our in a bucket for us to do. We have started to discuss, how we want to decouple applied state from derived state. I think there's something that within the design team, we have still got some more discussion and alignment to take place. Then, of course, as MPLS base comes along, we want to make sure our model, LDP and MLDP, is well in alignment with LDP, MPLS base. And then based on netmod direction, if that recommendation comes along to be something different, we want to make sure we're in alignment with that as well. Of course, that's going to continue on whether, even after the working group adoption, based on when those other drafts get revised or recommendations get changed. So really the next step here is to request for adoption. It's version 3. I think the design team has done a tremendous amount of work to get the model in really good shape, and it's gone through some reviews. So that would be it. Thank you.
Any more questions?
Thank you.
Okay, well, I think that was a really useful session. I found it very helpful. I want to thank my co-chairs for putting this together, all of them, even the ones not here, and also a special mention to Matt Hardley for putting together the agenda. He worked hard. Thanks to all the presenters. That was really good, and the people who came to discuss at the mic. I think you've helped move things forward. So that's the end of our agenda. We're finishing a couple of minutes early. Thanks for that. I hope you all have a good evening, and remember to come to PC tomorrow. Yes, no sushi. Guess there's no sponsor.
Socials are not changing. I've been involved in a discussion about the social in Berlin.
Yeah.
And it's expensive.
Yeah, it's a lot for someone to step forward and do that.
Yeah, I mean, obviously the IETF was very important for a lot of us. So I don't think the internet would have been nearly such a success without good open standards, right? And a lot of companies and a lot of people have made some money off the internet. And a lot of people got a lot of value and use of it. So what we're doing is working. But it's still, someone's got to step up.
I think, yeah, someone else has to step up.